this one, 2 over 2, cancel, x minus 1, cancel, 2x plus 1, 2x plus 1 is the base, exponent subtraction, 4 minus 3, and get a factor. Put it in the parentheses, in the bracket. It's 2x plus 1 to the power 1. That's the first one. Then the second one is second one is here is 8 divided by 2, get 4, put it in the bracket. Then x minus 1 squared divided by x minus 1 remain parentheses x minus 1, because this over this, and same base, and 2 minus 1, got to the power 1. And 2x plus 1 cube, factor out 2x plus 1 cube. This divided by this is 1. So if you distribute it in this one, if you distribute it in, you go back to this. Now you divide it and you got this factor. Now then you copy this greatest common factor down, and this 2x plus 1, and this distributive in, remove this parenthesis, get 4x minus 4, minus 4. Then this greatest common factor copy down. Then 2x plus 4x is 6x, and the 1 minus 4 is -3. Then factor out of 6 and 3. Common factor is 3, factor out. And this greatest common factor still copy down. 3 factor out. 6x divided by 3 is 2x. Put it in the parentheses. Minus still minus. 3 over 3 is 1. Then 3 times 2 gets 6. X minus 1. 2x. I put this first. 2x minus 1. And put this 2x plus 1 cubed. If you want to put this exchange, it's okay. You want to put this first and put this. It's okay. It's equal. They are equal. No problem. It's okay. So this one, use the product rule and use the power rule and use the chain rule to do 3 rules together in one question. 27. And this have a power, so first of all use power rule, and the inside is a quotient, and use quotient rule to do. So first of all use power rule. The 3 go from and this base to the power 3 minus 1, and then chain rule, this base take derivative, and since quotient, so use quotient rule. Then take derivative, this base take derivative, is denominator square, then numerator take derivative, x plus 3 take derivative is 1, times denominator, x minus 2, minus numerator do not take derivative, times denominator take derivative is 1. Then it's a 3, and this base, and 3 minus 1 is 2, times this x minus 2 quantity square, x minus 2 minus x, then remove the parentheses, plus change to minus 3. Then multiply. So 3, this square go into each base, get 3 plus x plus 3 quantity square, and then this go into each base on the denominator, x minus 2 square. This x minus x is 0, -2, -3. So it's -5. So those times on the numerator, times -5. And those times on the denominator, x minus 2 square. Then this x minus 2 square, x minus 2 square, same base is x minus 2. Then exponent add together, 2 add 2 is 4. 3 times -5 is -15. Then x plus 3 to the power 2. Then next one also is similar to this. So similar to 27. So first of all, use power rule. 3 over 2 to the from, and base is this, and 3 over 2 minus 1 times, and this base take derivative. Since it is a quotient, so use quotient rule. Quotient rule is denominator squared, and the quotient rule, I write down quotient rule, it's f over g prime equal to g squared f prime times g minus f times g prime. Quotient rule. So then you got here use quotient rule, denominator, which is 2t plus 1 quantity square. Then numerator take derivative. T take derivative is 1. Denominator do not take derivative. Copy down 2t plus 1. Put it in the parentheses. Minus numerator do not take derivative. Still t. Times denominator take derivative. 2t plus 1 take derivative is 2. And then you combine. So 3 over 2 and this base. Copy down. And 3 over 2 minus 1 is 3 over 2 minus 2 over 2. Get 1 over 2. Then 2t plus 1. T times 2 is 2t. So minus 2t over denominator. And then 3 over 2. Then this 1 over 2, use power rule, go into power rule of quotient. This 1 over 2 go into each base. Get t to the power 1 over 2. 1 over 2 go 2t plus 1. Get 2t plus 1 to the power 1 over 2. Then this 2t minus 2t is 0. Get 1. Denominator is 2t plus 1 squared. So those times together is 3t to the power 1 over 2. And this same base, 2t plus 1. 1 over 2, add 2. So 2 times 2, add 1 is 3 over 2. It's 5 over 2. This is 5 over 2. So you can practice it, and then you can get familiar with those practice. Now, next question. Question is, first of all, this is a radical, so we change to exponent. So this is to the power 1, 1 over 2. Exponent become 1 over 2 to exponential form. Take derivative. This take derivative. So 1 over 2 go from, and this is a base, copy down. Then minus 1. 1 over 2 minus 1. Power rule. And then times by the chain rule. By chain rule, this base take derivative. This is a quotient, so use quotient rule. 3 plus 2 squared. Numerator take derivative. U plus 1 take derivative is 1 times the base. 3u plus 2. Minus the numerator, it's u plus 1 times denominator. 3u plus 2 take denominator is 3 times by 3. And then equal 1 over 2. And this 1 over 2 minus 1 is 1 over 2 minus 2 over 2 is a negative 1 over 2. The base is still this. And this 3u plus 2 quantity square, and numerator distributive in is 3u plus 2 minus distributive in minus 3u. Distributive in negative times positive. So you got negative minus 3. And then this use the this base negative 1 over 2. This exponent go into each base. This we call power rule of quotient. Power rule of quotient is a over b to the power n equals a to the power n over b to the power n. This exponent go into each base, and this is a quotient. This we call power rule of quotient. So negative 1 over 2 go u plus 1 base. negative 1 over 2 go 3u plus 2, and 1 is on numerator. So this on numerator and this on denominator too. Then this combined, 3u minus 3u is 0. 2 minus 3, it's a negative 1, put on numerator. 3u plus 2 square, put on denominator. And then the numerator is negative 1. And this is negative exponent. Bring down to the denominator, become positive 1 over 2. And this bring down, okay, this. And 2, still 2. And then this is a 3u, this with this. Negative 1 over 2, add 2 is a 3 over 2. It's the same base. Tying together is a 3u plus 2 to the power 3 over 2. And then this negative 1 still negative 1 on numerator. This negative exponent bring down to the denominator is 1 u plus 1 to the power 1 over 2. And here has 2, still 2 there. So next one, number 30. We call implicit differentiation. Implicit differentiation. Because here this function, this equation, is very hard to write y in terms of x. You cannot solve for the y. It's hard to solve for the y in terms of x and take derivative to find dy dx over dx. You cannot write y in terms of x and so get dy over dx. So we just use, we call implicit differentiation. What is implicit? So first term x squared, both sides take derivative. Left side take derivative to the x. We do d over dx, and function is this. Equal d over dx, 10 take derivative. Put d function over dx. Both sides take derivative to the x. It's right this way. So x squared take derivative to the x is 2x. And plus 5. 5 is scalar. So take derivative is still 5. Then x times y, take derivative to the x and use product rule. So product rule is f times g, take derivative equals f prime times g plus f times g prime. Product rule. So x times y, take derivative. X take derivative to the x, dx to the x is 1 times second function do not take derivative is y plus first function do not take derivative is x times second function take derivative. Y take derivative. So since we don't know y in terms of x is what, we don't know, so we just leave as dy over dx take derivative. And the plus the third term, y squared take derivative. Use power rule. First of all, use power rule. 2 go from, and 2 minus 1 is 2 times y. Times by the chain rule, y in terms of x, but we don't know. So we just take derivative is just dy over dx equal. Constant term take derivative. 10 take derivative is still 0. Is 0. Then remove the parentheses. So 5y and 5x times dy over dx and plus 2y times dy over dx equals 0. Then combine like term, which is to this one and this one both have dy over dx. You can factor out dy over dx and factor out dy over dx, put it in the parentheses, 5x plus 2y. And move this 2x to the right side, plus 2x change to minus 2x. Move this 5y to the right side, or you do subtraction property, minus 2x cancel, become 0 minus 2x is negative 2x. Minus 5y, cancel, become minus 5y on the right side. The quick way is move over, and 2x moved, change to negative. 5y moved, change to negative 5y. And then divide both sides by 5x plus 2y. This cancel and get dy over dx equal this side divided by 5x plus 2y. So you got dy over dx, right? It's this. This we call implicit differentiation. And next one, implicit differentiation. First of all, you write exponential form. This is use negative exponent, positive 3, switch up to the numerator, become x to the power negative 3. This y also switch up, become y to the power negative 3 equal 5. Then left side take derivative to the d, this function dx over dx equal. Right side take derivative d over dx to the 5. Both sides take derivative to the x. So left side use power rule, negative 3 x to the power negative 3 minus 1. And x take derivative is 1, so times by 1, so you don't need. So plus, this use power rule, negative 3 go from y to the power negative 3 minus 1, so it's negative 3 minus, times the y take derivative. Y is in terms of x, but since we don't solve for this to get y in terms of x, so we call implicit. So write dy over dx equal 5 constant term take derivative is 0. Then negative 3x, negative 3 minus 1 is negative 4. And then positive times negative is negative 3. Y to the power negative 3 minus 1 is negative 4. And dy over dx times dy over dx times equals 0. Then solve for dy over dx. So move this term to the right side, or you add this term on both sides. So become minus, change, become plus 3x to the power negative 4. Then solve for dy over dx, both sides divided by this, done. This divided, cancel, and get dy over dx, and this side divided by. Then 3 and the 3 cancel, get 1. And negative, you can put it in front of fraction, negative sign. Negative b over a over b, negative a over b. You can put this negative sign on numerator, or you can put this negative sign on the denominator. They all equal. They all equal. So this negative sign you can put on in front of fraction. This y to the power 4. Switch to the up, become positive 4. And this x to the power negative 4. Switch down, become x to the power positive 4. So we leave answer with the positive exponent. So get final answer. And this differential of the function. And what is the differential of function is this. Is dy is equals dy over dx. And you can put d is y prime. Y prime. And then it is differentials. Both sides times dx. So it's dy equals y prime dx. If you use the function, it's df of x. If I don't put this, simplify like this. df of dx, that is f prime. F prime is df over dx. Then it is differentials is df equals f prime times dx. Both sides times dx. This is differentials, which is dy equal y prime dx. So this function, first of all, you do this function, take derivative, f prime. This is f prime of x. F prime of x, right, in D is d f of x, take derivative to the x, equal. And this use quotient rule because it's quotient. Use f of x is this function take derivative. Quotient rule, x squared plus 1 square. Quotient rule, denominator square. Numerator, take derivative. X minus 1, take derivative, is 1 times denominator, x squared plus 1. Minus numerator is x minus 1. Denominator, x squared plus 1, take derivative is 2x. Then distributive in. Remove the parentheses. So first of all is x squared plus 1, and minus 2x times x is minus 2x squared. Minus minus become plus. Then 2x times 1 is 2x. Combine like term. X squared minus 2x is a negative x squared. 2x plus 1 over x squared plus 1 squared. So this function take derivative, use quotient rule, and we got this. Use quotient rule and the power rule, we got this. Then you do d f of x equals this f prime, which is this, times dx. Both sides times dx. df of x equal this dx cancel and times over here, and got this. That's the answer.